let's begin our look at exponential functions by evaluating a very simple example. Here we have the exponential function y equals 6 times 1/2 to the x power. This falls into the larger category of exponential functions because of our positive base right here and our variable exponent right there. Similar to the other functions that we have looked at throughout the year, this 6 serves as a scaling or potentially reflective constant in front of what we know as the exponential function. We're going to evaluate this function at the number x is equal to 3. Just as we have done for every function throughout this year, we're going to use that 3 in the place of x and follow the order of operations to evaluate. Y equals 6 times 1/2 to the third power. Exponents come before multiplication. 6 times 1 to the 8th, which is 6/8, which simplifies to 3/4. So we know that this graph will go through the point 3, 3/4. The fact that this base is less than 1 indicates to us that we should anticipate smaller and smaller values of y as x increases. If I raise x to 4 and I evaluate that equation again, that's going to be 6 times 1/16, which is 3/8, half as much as the previous output, and giving us the point 4, 3/8. So we would expect, and a quick think about the graph of this function, we would expect that as the values of x get larger, this function is going to decrease. Sure, there's going to be an intercept in here somewhere, and we're probably going to see increase over there. We'll talk about that more when we get to the graphs. But the fact that this b was less than 1 was something that we should have noticed from the very beginning as contributing to the values of the function getting smaller as we move left to right on the graph.